first of all, let's discuss about the general formula of alcohols, and that is CnH2n plus 1 OH. OH is basically the functional group of alcohols, and this represents the general formula for alcohols. Okay, so let's move further and let's discuss about it. Do you know, like this formula RC double bond O dash OH? Do you think this is also an alcohol?
No, this uh is it an aldehyde?
No, aldehyde is not this one because in aldehyde we were having H, only H at this point. But this formula basically represents carboxylic acid group. This is carboxylic acid. This functional group represents carboxylic acid. So this is not an alcohol. And second thing, like for example, we have this benzene ring. And if we see about this ring and which group is attached to it, so this also doesn't represent to be uh, an alcohol. So they both are basically not alcohols. Okay.
Okay.
So for alcohols, remember one thing that their melting point and boiling point, they are relatively higher. Relatively higher. Why they are higher? Because of hydrogen bonding. Like for example, if you are having this ethanol, this is ethanol which is having this lone pair on oxygen and hydrogen is attached to it. So it's partial negative charge here and a partial positive charge here. So there's an other alcohol which is also an ethanol, and this is basically okay. So the force of attraction between this oxygen and this hydrogen, okay, that basically develops the intermolecular forces. So that represents the hydrogen bonding. So it is basically this intermolecular force represents the hydrogen bonding. So that is why we would be saying that alcohols would be having high melting point and boiling point. So if we move further and if we see about this thing, like just mm, okay, so we are going to have this one. Okay, so there is this hydrogen bonding basically also develops between water as well. So, you know, this is water molecule, and we know in water molecule, oxygen is having a lone pair. So we know that in hydrogen bonding, basically the force of attraction that is developed between a lone pair, between the atom which is having the lone pair, that is either oxygen, nitrogen, or fluorine, and their attraction with hydrogen. That is basically represents hydrogen bonding. And we know about one thing that this oxygen and this hydrogen develops a hydrogen bonding. Okay, that is why alcohols would be having higher melting point and boiling point. And you can see that this hydrogen bond basically also developed between water molecule and ethanol as well. So because of that, what actually happen, alcohols, they are very soluble in water, very soluble in water. Is that clear?
Yeah.
And the reason is quite simple, because alcohols develop hydrogen bonding with water, with water. Okay?
Okay.
Yes. So let's move further. So what happens? Their solubility actually, their solubility actually decrease with increase in size, with increase in size of alcohol. What we actually mean by this thing, like for example, this is ethanol, and sorry, this is methanol. And if you're having ethanol C2H5OH, then what does it means that basically ethanol, this ethanol solubility in water is less than less than methanol. That means as the mass is getting bigger, okay, so the solubility in water is basically decreasing. If I would show you a molecule, like for example, we are having this one, CH3, CH2, 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 then CH2. So they are like 3, 4, 5, 6, 7. 3, 4, 5, 6, 7 dash O dash H. So what we actually mean by this thing, that the water attracting molecule is basically not this one. This part is not basically attracting water. This is basically a non-polar chain, okay? And does not attract water, and it does not attract water. However, this part, only this part is basically water attracting. Water attracting. Is that clear, Sultan?
Yes.
Okay. So let's move further and let's discuss about more things in detail. First of all, let's discuss about the new topic, and that is formation of alcohol. Okay. So if you're
Okay.
discussing about formation of alcohol, the first one is hydration of alkenes. Hydration of alkenes. What we mean by hydration? Hydration means addition of water. Addition of water. So if we are adding water in alkenes, they are going to make alcohols. Like for example, we are having this ethanol, this alkene, and which is basically ethene. This is ethene, So if we are adding water in it, then what is going to happen? This reaction basically occur in the presence of catalyst, and that is H3PO4. And this reaction basically occurs at 300 degrees Celsius, 300 degrees Celsius, and this occurs at 60 atm pressure. So what is going to happen? We know that it contains H and OH. So one H is going to attach at this point and OH is going to attach at this point. So it would become CH dash H and H. Okay, we can also write H here as well, or even OH as well. Both are fine. So we are going to add OH here. So you have seen this double bond is basically changed into single bond. Why? Because these two electrons has been transferred to these points. Is that clear, Sultan?
Yeah.
Okay. So the next reaction is basically nucleophilic substitution reaction. Substitution reaction. And we have discussed with, SN1 and SN2 reactions of halogen alkene. Okay, do you remember them?
Yeah.
Okay, so what is going to happen here, that we are having this chloromethane. This is chloromethane. And what is going to happen, that we are going to add sodium hydroxide. And you remember I have told you about a reflux, okay,
Yeah.
heat reflux reaction that is going to proceed here. So what is going to happen? We know this OH is going to replace this chlorine, which is having partial negative charge, and this is some partial positive charge. So we know that OH is going to attack on carbon. So it is going to replace it, and it would be forming OH like this, and chlorine is released from it like this. Is that fine?
Yeah.
Okay. So the next reaction is basically formation of glucose. Oh, sorry. That is basically fermentation of glucose. Do you know what is fermentation of glucose?
No.
Okay. So in the fermentation of glucose, what actually happened? We are having this uh, sugar molecule C6H12O6. This is glucose. And what is going to happen? Fermentation is a process that actually occurs in the absence of oxygen and in the presence of catalyst, that is yeast. So temperature here is between 25 degrees Celsius to 35 degrees Celsius, and this reaction basically occurs in absence of oxygen, first thing. And the reaction that occurs in absence of oxygen, we call that reaction as anaerobic, anaerobic condition. Okay, that represents the reaction that occurs in the absence of oxygen. And what actually happens, there is basically ethanol that is going to form here with the release of carbon dioxide gas like this. Okay, so what is going to happen? The important thing that I want to discuss here, that this reaction has a very low yield. Why we are saying that this reaction is yield means production. So this reaction is going to have a very low yield, and the reason is that because when alcohol is created, it would basically kill the yeast. Okay. As we know that
Okay.
this alcohol has been created, so it is basically going to kill the yeast. Okay. So that is why this reaction has a low yield. And now what we are going to do, we are going to remove this ethanol by a process which is basically called as distillation. Okay. This process is called as distillation. So when this ethanol is formed, we are going to remove it with the process of distillation. And the important thing here that this reaction occurs in the presence of yeast. Temperature is 25 to 35. The reason why temperature is 25 to 35, because after that temperature, if we increase the temperature, this yeast would die. And if this yeast would die, then the reaction would not proceed. Is that clear?
Yeah.
Okay. So one more important thing, if air is present here, now what is going to happen if air is present? So if air is present, then what is going to happen? This alcohol, the alcohol is basically oxidized to form what? It is oxidized to form carboxylic acid. So that is why we don't require oxygen. Because if oxygen is present, then this alcohol has been oxidized to form carboxylic acid. So that is why we basically prevent the uh, presence of air in this reaction. Is that clear, Sultan?
Yeah.
Okay. So let's move further and let's discuss about what are basically primary alcohols and what are secondary alcohols and what are basically tertiary alcohols. Okay. So if we see about primary alcohols, the primary alcohols are the one in which there is two hydrogen group is attached and only one carbon group is attached here. So this represents the carbon, or you can say the alkyl groups is attached here. In secondary alcohol, there would be two alkyl groups that would be attached with it and only one hydrogen with one functional group. Here, there would be three alkyl groups like this. Okay, there would be three alkyl groups like this, and there would be one functional group. I hope you have come across the difference between them. Okay,
Yeah.
so now let me show you one formula, and that is this one. Okay, so there is OH group that is attached here, and this one would be another group that is OH here. It is basically like this. Okay, so now there's one OH group that is attached here. So let's see which one is primary, which one is secondary, and which one is tertiary. Now, my question from you is that if there is nothing attached here, so what do you think at this point, how many hydrogens would be there?
Sorry, I don't understand.
I'm saying how many hydrogens would be at this point? We know about the skeletal formula. If it is
Yeah.
like this, and do you know what is attached here?
Two.
What is attached at this point?
Oh, hydrogen.
Hydrogen. How many hydrogens would be there?
Two.
Two. Great. So we know that there is one carbon here and two hydrogens here. Is that clear? So
Yeah.
we know where we are having two hydrogens and one carbon group. So that would be actually primary. This one is primary. So this represents the primary one. So that is basically primary alcohol. Is that clear?
Yeah.
Now, let's move towards this point. Now, we are having, at this point, if you can see, that we are having one carbon here, one carbon here, and one carbon here as well. So, what is this group called to be as? Yes,
Um, is it secondary?
no. If there would be three
Uh,
carbon,
no,
you can see if there would be three
tertiary.
carbon. Yes, that would be tertiary. Let's move towards this point. So this is having, is there any hydrogen which is attached here as well?
Uh, there is one.
Yes, here we are having one hydrogen. Here we are having carbon. Here we are also having carbon. So two carbon and one hydrogen. What that could be secondary or primary?
Secondary.
Great. So this one represents secondary alcohol. Is that clear?
Yeah.
Okay. So just want to tell you one important thing here, that we are having this primary alcohol, and when it undergoes oxidation, so when it undergoes oxidation, what is going to happen? It is primary alcohol, and when it undergoes oxidation in the presence of acidified K2Cr2O7 in a heat reflux reaction, we have already discussed this thing, and we can even use KMnO4 as well, but this one is basically preferred for this reaction. So what is going to happen? The primary alcohol is going to be changed into aldehyde, into aldehyde. Is that clear?
Yeah.
And then what is going to happen? This aldehyde is going to proceed further. If its oxidation is going to be done, then what is going to happen? First of all, its oxidation can be done in the presence of K2Cr2O7. You know, this reaction occurs in heat reflux condition. And first of all, we can use K2Cr27. We can also use Tollens reagent as well. Tollens reagent as well. So in Tollens reagent, what is going to happen? We are going to use this Tollens reagent is this silver amine. So in this reaction, what is going to happen? Silver would be reduced. Silver would reduce itself and would oxidize aldehyde. So silver would reduce to Ag, reduce to Ag condition. And what is the appearance of it? Silver mirror is formed. Silver mirror is formed in this kind of reactions. Okay. And that is going to form this carboxylic acid reaction. Sorry, carboxylic acid. Okay. So we have
Okay.
seen that primary alcohol, whenever they are oxidized, first they are going to be converted into aldehydes. And when aldehydes are oxidized, they are going to form carboxylic acid. Is that clear?
Yeah.
Okay, so I just want to explain one more condition. We have discussed these two
I
regions.
just have one question.
Yes, yes, Peter.
So in uh, this oxidations, is ketone involved in any of them?
I will tell you this answer later. Okay.
Okay.
So because you will get the answer probably in just next 5 to 10 minutes.
Okay.
So then we can also use Fehling solution as well. Okay, Fehling solution as well. So that solution is basically when copper plus 2, where copper plus 2, which is in basically blue color, gets reduced to copper plus, and they are going to have the red precipitate. They are going to form red precipitate. Okay, so basically these three reagents can be used for this reaction. Now let's move further and let's discuss about some of the more things. Okay, so we know about primary alcohol. Let's take an example. Let's discuss an example related to it. Like we are having a primary alcohol, which is this CH3, CH2, dash C, H, H, and OH. We know this is basically alkyl group, that is ethyl, and two hydrogen groups. So this basically represents primary alcohol. So when they are going to oxidized, what is going to happen? They are going to form, yes, what they are going to form when they are oxidized?
Is
Yes,
gonna
Bete?
form an aldehyde.
Great. It is going to form an aldehyde, and that is going to form like this. Okay. So this represents the aldehyde. And when they are going to oxidize further, so what is going to form? They are going to form carboxylic acid. Okay. Double bond
Okay.
O dash OH. So you can see that this is basically its reaction scheme. Okay. Uh, so one more important thing that I want to tell you, reaction does not stop at aldehyde that further oxidized to carboxylic acid. If we want to stop the reaction at this aldehyde, then what we are going to do, okay, we are instead of reflux at this point, if we are going to stop the reaction at aldehyde, like if we want to stop reaction at aldehyde, then what we are going to do, we are going to use instead of reflux, we are going to use distillation. Okay? Is that clear? We are
Yeah.
going to use distillation instead of heat reflux reaction. And remember one thing, the important point here, aldehyde would have low boiling point as compared to alcohols. Aldehyde would have low boiling point as compared to alcohol, and the reason behind is that as they don't have, yes, as they don't have OH group, OH group to form hydrogen bonds, to form hydrogen bond. Is that clear? So
Yeah.
this is very important that aldehyde would be having low boiling point as compared to alcohols, Why? Because they can't form hydrogen bond. Okay. So now let's move towards secondary alcohol, and now you will be able to get your answer for the question that you have asked before. Secondary alcohol, when they are going to oxidized, okay, in the presence of the same reagent, that is acidified K2Cr2O7, and in a heat reflux reaction, so what is going to happen? A ketone is going to form. So ketone is basically forming from secondary alcohol. Okay. And remember one thing, when ketones are formed, so ketones won't oxidize. Okay. Ketones will not oxidize further. We have discussed that aldehydes would be oxidized further to carboxylic acid. But in the case of ketones, when secondary alcohols, they are oxidized to form ketone, they will not further oxidized. Ketone don't oxidized further. So this is basically, you can say, a major difference that lies between aldehyde and ketone. Sultan, is
Okay.
that clear?
Yeah. And what about if you oxidize the tertiary alcohol?
Oh, okay. I will tell you that after this one. Let me
Okay.
give you an example of secondary alcohol. So that is basically this one. Which group is attached here? We know that secondary group would be having two alkyl groups. So this is one and this is two. And when they are oxidized, so what is going to happen? A ketone is formed like this. Is that clear?
Yeah.
Okay, great. So now remember that tertiary alcohol, they don't get oxidized. They don't get oxidized. Is that clear?
Yeah.
And now let's take some of the example as well. Like if you are given with this kind of question, okay, and this is basically which group is attached here. Okay, let's discuss first of all which one is primary, which one is secondary, and which one is tertiary. So if we look at this one, this is OH group, and here we are having two hydrogen groups. Am I right?
Yeah.
So if we are having here two hydrogen groups, then what do you think this one would be? This one would be a primary alcohol, secondary alcohol, or tertiary alcohol with two hydrogen and one carbon.
Primary.
Yes, very good. This is primary. So what do you think this point would be? As you know that it is having one and it is having only one hydrogen here. Okay. So this one would be a primary, secondary, or tertiary.
Secondary.
Great, very good. So what do you think this one would be? A primary, secondary, tertiary. This is basically CH3 group here, and this is CH2 group here, and this is also CH2 group here. Yes, so what do you think this one would be? Primary, secondary, or tertiary?
Tertiary.
Great. So this is tertiary. So if we have to oxidize it, if we are oxidizing it, then how we are going to draw the structure? We know this is tertiary, so tertiary would not be having any kind of difference because it is not oxidized. So this is basically a secondary group, this OH group where OH group is attached. So this is a secondary group, and what is going to happen with the secondary alcohol? They will be oxidized to form
A
Ah,
ketone.
great. So I'm going to put double bond with oxygen like this because this is the representation of a ketone in a skeletal structure. And here in the primary alcohol, what I'm going to do with it, this is OH group, and I'm going to attach this double bond here with oxygen because we know that this is represents the actually this is basically a carboxylic acid group. So this one would be changed to this one. Is that clear?
Yeah.
Okay. So let's move further. And now you are going to attempt some of the questions by yourself. And in the next 7 minutes, and I'm going to send the link again, you have to complete these questions.
Okay.
This is OH group. Okay. And this is another OH group. And then we have this question number 2, and that is this is OH group. And okay. So now you have to tell me that which one would be oxidized and how it would be oxidized, and which one would be primary and which one would be secondary. So kindly complete this work. This is OH group. And then when I will rejoin it, I'm going to ask you questions.
Okay. So I have.
So let's discuss about reaction of alcohols. So the first reaction, which is very important, and that is dehydration of alcohol. Dehydration of alcohol means the removal of water from alcohol. This means removal of water. How it is going to happen? Like for example, we are having this one. This is C dash C dash C. So this one would be H, H, H. This is H. This is H. This is H, and this is OH. And this is H, H, H. Okay. So
Yeah.
first of all, what is going to happen if uh this is removed? This OH and this H is removed, then what is going to happen? The double bond has been created here. So that would become C dash C dash C double bond C. Are you getting my point? This one
Yeah.
would become H, H. This is H, and this one would become H, 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 and this is H with the removal of water like this. And what happened if this H and this OH would be removed? Then what is going to form? C dash C. Double bond would come at this place. Okay. This is H. 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 And this is H. This is H. So if you can see here that when this H and OH has been removed from these places, then what is going to happen? A cis trans formation occurs. Cis trans isomer has been created. Is that clear?
Yeah.
And then what is going to happen after that? Let's discuss about the conditions which are related with it. So condition number 1 states that if you're using aluminium oxide and we are going to heat it, then what is going to form? Like for example, this is alcohol And when it has been passed through this heated aluminium oxide, then alkene would be formed. Okay. Second condition that we can use either condition. Okay. So these two options are available. That is concentrated sulfuric acid. If concentrated sulfuric acid has to be used, first of all, that is used as a dehydrating agent. Sulfuric acid is used as a dehydrating agent. So what happens in this, like for example, this is alcohol vapor, and when they are going to enter from this delivery tube, so when they are going to enter from this delivery tube to this beaker, which basically contains this concentrated sulfuric acid, then what is going to happen? You can see that they are going to form alkene. Is that clear?
Yeah.
But remember one thing, this concentrated sulfuric acid is also a very good oxidizing agent. Good oxidizing agent. Oxidizing agent means that basically oxidize other substances. Good oxidizing agent. So some alcohol can be oxidized. Uh, so alkene can be contaminated by acid. Okay. So some alcohol would oxidize to uh, carboxylic acid as well, which is basically contaminating the alkene. This contaminates the alkene. So some alcohol would oxidize to carboxylic acid, which would contaminate, what? Alkene. So in order to prevent it, what we are going to do, we must need to pass it through NaOH. We must need to pass through NaOH. Is that clear?
Yeah.
Okay. So this is whole about our today's lecture.